Let's talk about energy just for a minute. Remember that energy is not matter. You know, everything that has mass and takes up space is matter. So energy doesn't do that. It does flow, though, and it does change forms. Energy follows the same conservation rule that matter does. It doesn't just disappear out into nowhere, or it doesn't just pop up. So the conservation of energy is that you cannot create or destroy it. And the concept is that if you're using energy for something, that energy came from somewhere else, which came from somewhere else, which came from somewhere else. So like if you're baking bread in the oven, so your oven is heating the material and it's turning it into bread, and then that energy that is heating it came from the coils of the oven, which then came from the power supply, and then it goes back to your power supplier, maybe it's EPB, and then they get it from somewhere. So the energy that's used, it keeps getting recycled and reused. It doesn't just come from nowhere. A specific type of energy that we're going to be talking about is heat energy, and that is represented with a Q. Now, energy is a little bit different than mass when we have positive and negative. So if you had 100 grams of something, you're like, yeah, you could weigh out 100 grams. Can you weigh out negative 100 grams of something? No, because you can't have less than 0. For energy, though, energy, the units would be joules. And with energy, the positive and the negative is tell us flow. So if you have a positive, then that means that that's energy going into the reaction or the phase change. It's going in, and we'll also say that it absorbs. If it's a reaction, then we will say that it is endo. Endo meaning in, endothermic. And then if it's negative, it means out. It means it releases energy. It makes other things get hot around it. And if it's a reaction, it's exo, meaning out, thermic. Sometimes I like to think that as money. The endothermic reactions like to keep their bank account positive. They require payment for the reaction to happen so that they always stay positive. And the exothermic reactions are the ones that are super generous, and they are willing to give out energy, money, even if their bank account goes negative. And in fact, it does go negative. The more that it gives out energy, the more negative something becomes. All right, so chemical energy, where does it come from? Well, when you're doing a reaction, you have bonds, and those bonds are broken in the reaction. So there's energy in the bond, and when the bond is broken, energy is released. But on the other side of the reaction, the bond will be made with someone else because there's energy and they don't like to not be bonded up. So maybe it'll be a new bond, and it takes energy. It'll absorb energy to do that. When these are the same, which is like rarely, there's no difference in the temperature of the system. But when one is like larger than the other, that's how you'll end up with an exothermic or an endothermic reaction. The exo is when you have extra energy and it gives off as heat. And the endo is when you don't have enough and you need more, and it absorbs heat from the surroundings. Last but not least, thermodynamics is the study of the flow of energy. Sometimes we call it the flow of thermal energy. And actually, I do have one more piece of information. In chemistry, we talk about the chemical reactions, and that's one way that we deal with energy. Another way that we see energy is in a phase change. So a phase change is when it goes from being a solid to a liquid to a gas. That moment that they change over, those are phase changes. And the temperature will increase up to a certain point. So let's say it's a temperature and it's 25 degrees Celsius. It'll keep increasing and increasing to 100. And then the crazy thing is that when it's at 100 degrees, it won't keep increasing in temperature on a hot plate. It will stay at 100, and instead, all these molecules will start separating apart and they'll become a gas. And so a phase change is when the energy is used not to increase the temperature, but to change the phase. So those are the two main ways that you'll see thermal or heat energy used in chemistry.